two vectors x and y have equal magnitude. Okay, so it's given that mod of x is equal to mod of y. The magnitude of x minus y is n times the magnitude of x plus y. So it's given that magnitude of x minus y is equal to n times the magnitude of x plus y. Okay, see, so we have been doing this question many a times. We have used this identity many a times, that if modulus of a minus b is equal to modulus of a plus b, then we know that the angle between them, theta is equal to cos inverse 0, which is theta is equal to pi by 2. Okay, so what we need to understand here is there's only one minor difference. Instead of a plus b, we have here n into a plus b. That's it. But the angle cos inverse 0 is going to remain the same, right? So what do we need within the argument of cos inverse is actually 0. Now, if this n is equal to 1, we directly get this value, cos inverse 0, right? Which means the correct option here should obey the same logic. If you substitute n is equal to 1, what should this become? It should become cos inverse 0. Let us see which are options have that. So first option is cos inverse n square plus 1. It is 1 plus 1 by n is equal to 1. 1 minus 1, division by 0 is not defined. Then we have minus 1 by 1 minus 1. Again, division by 0 is not defined. Third option, 1 plus 1 by minus 1, which is 2 by minus 2 is minus 1, which is not the case. So what you get is cos inverse minus 1. That's wrong. The last option, option D, what you get is cos inverse 1 minus 1, the whole upon minus 1 square minus 1, which is equal to cos inverse 1 minus 1 is 0, 0 by minus 2, which is equal to 0. Therefore, the correct option is option D. Right, so very straightforward approach of this equation. Now, if you were to solve this question for a subjective exam in a detailed answer, how do you do that? Let us have a look at that too. So what we'll do is, we'll write down the identity first. Given that mod x minus y is equal to, okay, I'll use the vector sign also, x minus y is equal to mod x plus y times n. Also given that modulus of vector x is equal to modulus of vector y. Now, what is modulus of x minus y? We know that it is root of x square plus y square minus 2 into xy cos theta, which is equal to, what is modulus or root of x plus y? It is root of x square plus y square plus 2 into xy cos theta. And what do we have here? Into n. And if we square this on both sides, what do we get? What we get is x square plus y square, sorry for the interruption, minus 2xy cos theta is equal to x square plus y square plus 2xy cos theta, the whole into n square, right? In which case we can write this as x square plus y square. Okay, I'll write it detailed. Minus 2xy cos theta is equal to x square n plus y square n plus 2xy cos theta into n square. Okay. Now, I'll bring these two terms to the LHS. So what we get is x square plus y square minus x square n minus y square n is equal to, I'll take this term to the RHS, is equal to 2xy cos theta into n square plus 2xy into cos theta. Now, if I take n square common from here, what do we get? What we get is x square plus y square, right? Oh, okay, wait, sorry, my bad. If we take, okay, let me rearrange this. So x square plus y square minus, I write this as n square into x square plus y square, right? Here I'll take n square common. What else do we have? Sorry, here we'll have to take 2xy common, 2xy into cos theta common. So within brackets, what we get is n square plus 1, right? So going even further, if I take x square plus y square common here, x square plus y square common from the first two terms, the LHS, we get x square plus y square into what is left? 1 minus n square is equal to 2xy cos theta into n square plus 1. And have a look here. Modulus of x is equal to modulus of y, which means we can write x is equal to y. So x square plus y square will be x square plus x square, say, into 1 minus n square is equal to x equal to y implies 2 into x is equal to cos theta into n square plus 1. X square plus x square is 2x square. 2x into 2x is 2x square. So we have 2x square into 1 minus n square is equal to 2x square into cos theta into n square plus 1, and 2x square by 2x square is 1. So what we get is cos theta is equal to 1 minus n square by n square plus 1. Which option is that? 1 minus n square. Okay, there's no option present, which means we'll have to multiply this by minus 1 on both numerator and denominator. Now what do we get? Now what you get is n square minus 1 by minus 1 minus n square, which is the correct option, option D. Okay, so that's question number 19 for you. Moving on to the next one.